Row reduction, more examples. In this video, I'm going to go through two more examples of the row reduction algorithm. Let's keep all the steps of the algorithm on the screen so it's easy to follow along step by step. Let's start with a linear system of three equations in four variables. And let's also go ahead and write the augmented matrix for that system. Okay, let's move this to the bottom so we have some room. And let's start with step one, where we find the leftmost non-zero column. That's the column all the way to the left, which is 1, 0, 1. Next, we select a non-zero entry in the pivot column. We might as well choose this leading one in the upper left because it's in the pivot position, so we don't have to interchange any rows. Next, we want to create zeros in all positions below the pivot using row replacement operations. So we first just rewrite the first two rows. We can rewrite the first row because it's the pivot row, and the pivot row never changes when performing row replacement operations. We can rewrite the second row because there's already a 0 in the position below the pivot in that row. So now we want to change row 3. Okay, so row 3 is the row that's changing, row 1 is the pivot row, and we subtract to cancel that out to 0. So now column by column, we have 1 minus 1 is 0, 0 minus 2 is negative 2, negative 1 minus 3 is negative 4, negative 2 minus 4 is negative 6, and negative 6 minus 5 is negative 11. Great. So now we ignore the row containing the pivot position and all rows above it. So let's just put a light line through that first row since it's going to be ignored from now on. And we go back to step 1, where we find the leftmost non-zero column. That would be this column, 1, negative 2. Let's select a non-zero entry in this pivot column. Let's choose that 1 there. Again, this is already in the pivot position, so we won't have to interchange rows. Next, we're going to create zeros in all positions below the pivot using row replacement operations. Okay, I rewrite the first two rows. I can rewrite the first row because we're ignoring it for now. And I can rewrite the second row because the pivot row never changes when performing row replacement operations. Let's go ahead and change that third row. We're changing row 3. Row 2 is the pivot row. We multiply row 2 by 2 to make them match up, and then add to cancel. So again, column by column, we have 0 plus 2 times 0 is 0. Negative 2 plus 2 times 1 is 0. Negative 4 plus 2 times 2 is 0. Negative 6 plus 2 times 3 is 0. And negative 11 plus 2 times 6 is negative 11 plus 12, which is 1. Okay, now this matrix is now in row echelon form. Notice that there's a pivot in the rightmost column. And remember, whenever this happens, the original system of equations has no solution. Let's look at another example. Here we have a linear system of 4 equations with 4 variables. Let's go ahead and write the augmented matrix for that system. And now we find the leftmost non-zero column. That's this column, all the way to the left, 0, 0, 2, 2. Let's select a non-zero entry in this column. How about this 2 here? And notice that this entry is not in the pivot position, which is all the way on the upper left. So we're going to have to interchange row 1 and row 3. And this is what we get when we do that. Next, we're going to create zeros in all positions below the pivot using row replacement operations. We only need to get a 0 in that last row, and we could do that using the row replacement operation row 4 minus row 1. Let's go ahead and rewrite the first 3 rows. We can rewrite the first row because the pivot row never changes when performing row replacement operations. And we can rewrite rows 2 and 3 because there are already zeros below the pivot. Now, let's perform the operation, row 4 minus row 1. We get 2 minus 2 is 0. 0 minus 2 is negative 2. Negative 6 minus negative 5 is negative 6 plus 5, which is negative 1. 9 minus 2 is 7. And 7 minus 4 is 3. Next, we ignore the row containing the pivot position and all rows above it. So let's put a light line through row 1 since we'll be ignoring it from now on. And we go back to step 1 where we find the leftmost non-zero column. That's this column, 0, 2, negative 2. Let's now select a non-zero entry in this pivot column. Let's choose this 2 here, and we're going to have to interchange row 2 and row 3 to get that 2 into the pivot position. And we get this matrix here. Notice that we just interchanged those 2 rows. Next, we want to create zeros in all positions below the pivot using row replacement operations. So we just have to get a 0 in the 4th row there, and we'll do row 4 plus row 2 to accomplish this. Let's rewrite the first 3 rows. We can rewrite the first row because it's being ignored for now. We can rewrite the second row because it's the pivot row, and the pivot row never changes when performing row replacement operations. And the third row already has a 0 below the pivot. So let's go ahead and perform that row operation. Row 4 plus row 2 on the last row, column by column. 0 plus 0 is 0. Negative 2 plus 2 is 0. Negative 1 plus 3 is 2. 7 and negative 4 is 3. 3 plus 1 is 4. Great. Let's now ignore the row containing the pivot position and all rows above it. So we ignore the second row and the row above it, the first row. And we go back to step 1, where we find the leftmost non-zero column. That's this column 2, 2 here. And we're going to select a non-zero entry in this pivot column. Let's choose this 2. That's the natural choice because we won't have to interchange any rows. And now we create zeros in all positions below this pivot using row replacement operations. I think it's easy to see that we're just going to do row 4 minus row 3 here. Let's give ourselves a little room. Rewrite the top 3 rows. We can rewrite the first 2 rows because we're ignoring them, and we can rewrite the third row because the pivot row never changes when performing row replacement operations. Let's go ahead and do this last row. It's pretty easy to see that we just get a row of zeros, and this is because in the previous matrix, both of those rows are identical. So when we subtract, we get all 0. Okay, now what we have is a matrix that's in row echelon form. Let's continue to step 5 to get it into reduced row echelon form. So we're going to create zeros in all positions above each pivot using row replacement operations. Doesn't matter what pivot we start with. Let's start with this pivot and get a 0 in the position above it. So we have to change that circled 2 to a 0. And to do that, we'll do row 1 minus row 2. Let's go and rewrite the bottom 3 rows. The second row is the pivot row. That never changes during row replacement operations. And we just need to get a 0 in the position above the pivot in that row. So let's see, row 1 minus row 2. We have 2 minus 0 is 2. 2 minus 2 is 0. Negative 5 minus 3 is negative 8. 2 minus negative 4 is 2 plus 4, which is 6. And 4 minus 1 is 3. Great. Let's go to this next pivot of 2 here and change the negative 8 and the 3 to a 0. We'll start by doing row 1 plus 4 row 3 to turn that negative 8 to a 0. Let's rewrite the bottom 2 rows. Again, the third row is the pivot row. It never changes when performing row replacement operations. Okay, so we have 2 plus 4 times 0 is 2. 0 plus 4 times 0 is 0. Negative 8 plus 4 times 2 is 0. 6 plus 4 times 3 is 6 plus 12, which is 18. And 3 plus 4 times 4 is 3 plus 16, which is 19. All right, let's go ahead and do 2 row 2 minus 3 row 3 to eliminate that 3. And again, we'll do this column by column. 2 times 0 minus 3 times 0 is 0. 2 times 2 minus 3 times 0 is 4. 2 times 3 minus 3 times 2 is 0. 2 times negative 4 minus 3 times 3 is negative 8 minus 9, which is negative 17. And 2 times 1 minus 3 times 4 is 2 minus 12, which is negative 10. Okay, great. So all we need to do now is use scaling operations to make all of those pivots 1. So we're going to do 1/2 row 1, 1/4 row 2, and 1/2 row 3. Okay, let's give ourselves a little room here. And this is the matrix we get after we do all that scaling. Notice For the first row, half of 2 is 1, half of 18 is 9, and half of 19 is 9.5. For the second row, 1/4 of 4 is 1, 1/4 of negative 17 is negative 4.25, and 1/4 of negative 10 is negative 2.5. And for the third row, 1/2 of 2 is 1, 1/2 of 3 is 1.5, and half of 4 is 2. Okay, great. So what we have now is a matrix in reduced row echelon form. Let's write out the corresponding system of equations. We have x plus 9w equals 9.5, y minus 4.25w equals negative 2.5, and z plus 1.5w equals 2. Notice that the column corresponding to the variable w does not have a pivot, which means that w is free. Finally, let's get all the basic variables by themselves on the left by subtracting any term with the free variable to get x equals 9.5 minus 9w, y equals negative 2.5 plus 4.25w, z equals 2 minus 1.5w, and once again w is free.